So let's look at a couple others. What do we want? What is it going to look like actually if I say let's graph? So y equals, let's do the sine of x plus 2. Right. Well, now I'm taking, if I cover up the plus 2, I'm taking the normal sine graph, and what I want to do is I want to shift all of the coordinates up by 2. So having this extra little piece here, that's a vertical shift. Okay. And so let's look at what our input-output table is going to look like when we do that. Okay. So again, we're taking all of our thetas, but now my output values are going to be the sine of x plus 2. So you're going to get really good at using your input values as those same 5 over and over and over again. All right, so again, remember that the first thing that you want to do is you really want to write down what is the original sine outputs. So again, the original sine outputs, you can see them up here in pink. All right. Again, at 0, the sine of x is 0. At pi over 2, sine of x is 1. At pi, we're at 0, -1, and 0. And so what we want to do is when we have this extra plus value over here, that's going to say we need to add 2 to all of these original output values. All right, and so the operation attached to sine is, again, what we're going to do for sine. So now I'm going to be graphing the coordinates 0, 2, pi over 2 and 3, pi and 2, 3 pi over 2 and 1, or 2 pi and 2. And so this gives us the new coordinates where I'm taking this sine graph and shifting it up by 2. And so now it's going to be important that when you make your graph, that you can account for all of those values along the y-axis. Right. So again, 1, 2, and 3. And all of my domain or my input values, again, along the x-axis. Right. And so now let's graph the coordinates. 0, 2, which means now I'm starting here. At pi over 2, I need to go up to 3. Right. At pi, I'm at 2. 3 pi over 2 is at 1. And then again up here at 2. And so what you're going to notice is that when you make your sine graph, these 3 points that were normally along the x-axis are now all shifted up by 2. All right, and so you're always going to have, in the sine graph, 3 coordinates set on that axis, and you're going to have 1 max and 1 min. And so then let's identify our amplitude, period, domain, all of those. All right, so let's write down those 4 because we're going to be identifying these pretty much on every graph we make. And it's really easy to do once we make the graph. So your amplitude, all right? Again, you always, when you're looking for the amplitude, it's always this value right here in front of sine. That's your amplitude. And so whatever the number is that's sitting there, that's what you're going to use. Just like up here, 2/3 was my amplitude, that's the height. And again, that's the A value, or the absolute value of A. Right? And so when I come back down here and I look at this, there's no number written, which means that it's just automatically a 1. Period is still 2 pi. Domain still went from 0 to 2 pi. And now my range, the lowest point on this graph starts at 1, and the highest graph goes to 3. So the only other thing that we really need to focus on when we're talking about sine curves for today is not just what happens with a shift up or down, but what happens if we put, say, a negative in front, kind of how that affects things. All right. So I need more space here. All right, and so let's look at a graph. All right, and for today, let's graph y equals -2 times the sine of x. All right. And so now it's not just a positive value sitting right here, and there's a negative value. All right, so let's see what happens, how that negative is going to affect our picture. All right, again, I'm going to write down my little t-chart. My values along the x-axis, which are my 5 key points. Okay. Again, what I'm going to do is I'm going to write down what are the values that are my normal sine values. Okay, my normal output for sine values are 0, 1, 0, -1, and 0. And you're going to start getting really used to doing that. If you forget, just make a quick unit circle and look at what happens along the axes. But now I have to multiply, all right, by this value that's on the outside, just like we did when it was 2/3. I need to multiply those normal sine functions by a -2 because that's the number in front of sine. All right, and when I have a number in front of sine, it tells me to do that operation with that value. All right, so I get 0. Now my output's going to be a -2, 0. Negative times a negative becomes a positive, and then 0. And so when I make my graph, again, make sure that you label all of your tick marks nice and evenly spaced. It's super important that you do that. Don't ever have somebody try to assume what those hash marks mean, because these will change over time. So again, I'm plotting the point 0, 0. But now when I'm at pi over 2, I start by going down 2. All right, and so this is how the negative is going to affect things, is that instead of starting here and going up, the negative is going to flip or reflect the graph. And then I'm here. At 3 pi over 2, I go up 2. And then at 2 pi, I'm at 0. All right, and so what you're going to see is the graph is now changed. It's flipped upside down. And so what happens is when we talk about the amplitude, right, the amplitude is always the absolute value of A. So whatever that number is, we want the absolute value of it, because it still is supposed to just tell us the distance from this horizontal line to a max, or the distance to a min. And distance is always positive. So be very careful that you don't attach the negative when you're talking about amplitude. All right. Period is still 2 pi. All right. Domain is still from 0 to 2 pi. And then now my range, however, again, goes from -2 to +2. So be very careful when you are graphing these trig functions where there's a negative in front. But you're going to go through the same process. What are the inputs for that trig function, the normal outputs, and then how is the number on the outside affecting that particular graph?